All right. Welcome back to IT Security Labs, and thank you all for joining me tonight. I'm very excited to be sharing with you a Linux machine. And let me know, BT, if everything is working. It should be. I apologize for starting a few minutes late here because I was just verifying that my Security Onion is capturing everything and also make sure that we can see the detection events. Mike, it's good to see you, brother. Thank you for joining. Today's machine, I borrowed it from Hack My VM. If you are interested in Linux machines, this is definitely a place you should go and look for machines. I wanted to do Ping Me. I couldn't get it done in time, but this is the machine. It's called Responder. Please download it from here. As you can see, it's rated as a medium machine. That means that there shouldn't be anything difficult here. It's just a matter of figuring things out. And as soon as we figure it out, we should be able to attack the machine and get it done. Other than that, that's all we had today. Just a Linux machine. Let's see if we can learn about local file inclusion, what local file inclusion is, and also if anything, if we can actually detect local file inclusion. As you can see here, my Security Onion is capturing events. So without wasting time, let me go to my Kali Linux machine and let's do a simple ping on 192.168.38. I think, let me just check my IP address here. It's on 141. 141. So if you're curious what this looks like, let me show you. I think I can switch my screen here. This is what it will look like when you put this machine in your VirtualBox. It will tell you what its IP address is and who created it. So that's the view that you will have. All right. So let's make sure that it's responding. Once we verify, let's do an nmap here. -SV, -SC. Let's do on all ports because we don't want to miss anything. Remember what I always say, this is going for TCP ports, not UDP ports. And it's also just scanning IPv4 in this case. I didn't actually specify anything else. So let's see what comes out of this one. I should have done it -T4 or something like that. Then if we go to here, to our Security Onion, we should capture nmap already. All right, there we go. All right, I see ET scan for nmap here. I don't see a lot. Let me keep refreshing this. There we go. This just showed up right now. As Mike mentioned a few weeks ago, if you just scan with nmap, you might get caught. You need to specify nmap flags, and we actually did it after Mike's suggestion last time, where we were trying to hide nmap flags, but this is all nmap traffic right here. We can keep refreshing here. See if we keep getting more. Yeah, I see we are getting more and more. Let me see if I can see this in Kibana. I might have broken my Elasticsearch. I deleted some indices in here earlier trying to fix this. So let's see if it fixed itself. Otherwise, I might have to revert to a snapshot. Okay, I'll check on that in a little bit. But as you can see here, only 2 ports. And this is very interesting. You might notice that port 80 is actually saying it's open, but port 22 is saying it's filtered. I don't think we've experienced this on this channel before where a port shows up as filtered. So this actually caught my eye. Okay, it's a filtered port. What usually happens with filtered ports is either a firewall is filtering this port, like before we get to the host, or the host itself is filtering the port, meaning that we can't SSH on this port here directly. We need to do some gymnastics. Like, if the port is not allowing us get in, maybe in this case, since it's just a TCP port, we know most likely people play with IPv4 and IPv6 versions Or people might do an SSH on local host, then they would do like a tunneling method to get there. So this, regardless of what it is doing here, it's a filtered port. That's going to be interesting for us. But right away, we also see port 80 here, which is open. So the methodology that we have for a web application is always the same for us. We always go to the site and visit the web application. So let's just visit the site here. It's going to be on 141. You might notice that I'm using the browser from Burp Suite because I do intend on showing you how to use Burp Suite here. Right now, interception is off. If you have never used Burp Suite, you have to know how to use this. It's a wonderful tool. I highly encourage you to spend some time with it. It makes your life easier when interacting with web applications. So in this case, we're going to, here it says your answer is the answer. 4:22 is your time, and your time is running out. Whatever they're talking about, I don't know. I don't like this browser. Okay, let's just inspect this, I guess. I wanted to view page source. It won't even let me. Okay, so there isn't much here, as you can see up here. It's just a plain page anyway. The classic thing that I do by hand, so I did view page source. I don't have robots.txt. This is not good. So let's put this in GoBuster. Let me open a new tab here. Sudo. Let's use GoBuster here quick. GoBuster or DearBuster, whatever you like. I like this one. Let's choose the medium.txt one. That's a better option for me in this case. So this is the syntax for GoBuster. In this case, let me see if I can try to specify extensions, because sometimes this might take forever. 141. What extensions can I put? HTML.txt. I think it's this way. What other extensions can I specify here? .html, .php, .text. .php, .html. All right, so I'm looking for these extensions here because sometimes it just takes forever. So let's see if it doesn't bring me anything. Sometimes I do specify the status codes here if I'm getting too much information. But right now I do have an index.php, so I know this is a PHP site. Thanks, Mike. So I know this is a PHP site. This is probably the .php that we have here. So index.php is going to be our main page, unless if somebody's playing gimmicks. That's always the case anyway. All right, so we know index.php. And while we're running GoBuster here, I also like to run Nikto. Nikto is very loud. I don't like it for detection. If you have never run Nikto before, it's the loudest tool I know as far as when I'm dealing with this, louder than GoBuster. I don't know. It does a lot of tests that gets caught by Suricata. So Nikto, every time before I run Nikto, I kind of cringe a little bit because it's very loud. But let's check what GoBuster is doing to our intrusion detection system. Refresh that. All right. we should see a bunch of requests being sent by GoBuster here. I broke my suricata. Let me try to fix it. I deleted my index pattern in Kibana earlier in an effort to try to fix some issue that I was having, and it doesn't like it. But that's not a big problem. We can always recreate it. And the good thing is we can see our issues here. I wonder if this is going to affect how I'm going to be able to detect. Okay, so we don't have that index pattern here. It's missing. But this one should. Oh, this one should be the default. What am I doing? This index pattern should be the default, not logstash. How do I make this index pattern a default? I think this star. All right. So I recreated my Security Onion index pattern earlier, and I forgot to make it into a default index pattern. So it wasn't indexing. But that should work right now. All right, let's refresh that. Nothing? Okay. Let's see if we caught something here. Not yet. We're still looking. So we ran GoBuster to say, hey, show us any directories that you might find on this website that we are running on here. Because so far, we didn't find anything in the source. We didn't find any robots.txt. So we're sending a list of words that are very common to websites. We say, okay, can we see if any of these are going to actually match? So that's what we're doing here. And we're looking for text, HTML, and PHP. So this might take a while. While that is happening, let's go back to our problem. This is why you need to have snapshots of your systems, because when you start messing with things like the way I was doing here, you might end up with a broken system that might have to reinstall. So right now it's loading. I'm surprised Suricata is not complaining a lot here, because GoBuster is very loud. We might have to fire Nikto on this thing. Yeah, only nmap traffic triggered. Can I look at index pattern ID, whatever that is. Forget that. Let's go to the actual data. Today we're going to dig into the raw data. We're not going to have the work done for us. We're going to find out. All right, the last 30 minutes. All right, so this is us. When we ran nmap right here, you can see that we generated about 40,000 events just with nmap. If you narrow it down to this one section here, that's nmap. And here is another section where we're actually running GoBuster right now. If we look at this traffic here, we should be able to see that this is a bunch of requests that are being sent to one host. Yeah. Let's start with the first one. If you have never seen data that looks like this, you actually need to get comfortable with this, because it's really not that hard to be able to come and see like what's going on here. So first, we're going to 141, that's our victim. Back to, this is my Kali Linux. So this is a response that we're getting. Let's send the other way. Okay, we should see that we requested some random file location. Okay. This is interesting. I'm actually not seeing the actual request being sent by GoBuster. I was expecting to see them here. Surikata will catch them. Oh yeah, here it is. Here's a get method. HTTP user agent is GoBuster. Again, these tools are just very silly. If you use GoBuster, this is what you are working with. It's an HTTP not found because we are brute forcing using a word list. So every single word that we send and try that doesn't match on the host is going to bring HTTP not found. So if I go and search for these HTTP status message and put not found, equals to, I think I need to put quotes here for not found. I'm just trying to filter all the traffic for that was sent by GoBuster right now. In this time period, it should be a bunch of it. All right. So as you can see, these are all the requests that we are sending using GoBuster. It's very noisy too, and as you can see here, it's just a bunch of noise that we've been sending for a while. And actually, it hasn't found it. I should have specified my threads here. You know what? Let me do it again. I'm going to use the wildcard option with status codes. And let me change this to 141. So I'm using 20 threads here. That's minus T. That should be faster. This is not as accurate, but it does speed things up. I forgot to put it thread. So always put minus T if you want, because it's just ridiculous that it's taking forever. But anyway, as we do that, let's go find more traffic. Bana, how about you give me 10 minutes ago? We should see a spike because we are actually brute forcing at a faster rate. Okay, so this is the last 10 minutes. It's actually moving. Watch this bar, it's moving this way. Thank you, Mike. All right, if this takes forever, I'll just show you the one that it finds. Then we'll move on. I can come back to this later. Let's leave this one running. It does find file manager.php. So it finds this location here. So in addition to index.php, I'll go back and show you after it finds it. But for now, gosh, I hate this browser. This is the browser that comes with Burp Suite. It's annoying. It's like supposed to be Google Chrome. All right, so if you go to filemanager.php on the same website, now that we're hammering the same website, it might be a little slow. You get redirected back to here, which is not fun because we actually went to this location here. So this is where Burp Suite comes in handy. I want to know what's happening with this. Why? Why am I being redirected? So here's filemanager.php. Let's hit enter. No. That's not the request I wanted. I wanted this one. All right, so this is the GET request that we're sending to filemanager.php, which we will find right here after Burp Suite gets its work done. So why do we have a problem? Let's send this to repeater. This is why I really like Burp Suite, because then I can start seeing how things are working. Okay, so in repeater, and you know that I'm sending a GET for filemanager.php. If I hit a send here, I do see that I'm getting redirected. You can even like render if you had it here. I'm getting redirected just to the root, which is the slash directory. And what is the root of a website? In this case, it's index.php. So something is in that file manager.php that is telling it to redirect us to root. Either it has an identical contents as index.php, which is unlikely because that's kind of silly, or there's a part of this file here that says, hey, if somebody accesses you and they're not authenticated or something, send them to this location here, the root directory. So that's not ideal for us. Every time I find myself in this situation, I have to fuzz this file for local file inclusion. If you end up with a file that does something on a system, and in this case, it's redirecting us somewhere, I fuzz it for local file inclusion using wfuzz. That's just my default because I've seen good things coming from that. So let's actually see if I have wfuzz here. All right, hack tricks and hacking articles always have good things on wfuzz. So here are some instructions on how you can install wfuzz and also how you can even use encoding and all kinds of uses that you can use here. Hacktricks is a good location. So I just want to show you the resource that I always use. Hacking articles also is like a step-by-step, which is where I got this syntax here. But before I run wfuzz here, let me make sure that I'm not brute forcing some directories and wfuzz at the same time. That's really not good for me. I don't want to crash my system. All right, so you're going to have to take my word for it that this finally, after some time, I don't want to be here all night, it does find this file manager.php. So I'm going to stop this with go basta, and I'm just going to go with wfuzz. And I'll explain what this is doing here. This is my syntax. This is 141. So wfuzz will go and say, hey, we found out that you have file manager.php. Can I do a local file inclusion here? In this case, what parameter can I use in order for me to read files on the systems? So that's where this fuzz word is. You can use whatever word you want here. But in this case, I'm saying, hey, let's fuzz for any word. Sometimes it's like name is equals to or whatever. People put all kinds of things here depending on the application. So we're fuzzing for any parameter that comes here so that we can read files on the system. That's local file inclusion. In this case, etc password is always the default one. It's not always the file that you can read, but at least you will see like permission denied or something. Also, if it's a PHP or Apache site, I would also look for the logs. You know, there's a common log file that comes here. But in this case, I'm just fuzzing for that using a word list. In this case, it's just a web content command.txt. This one is the sec list one. So let's see what we can find here. Mine is complaining that I didn't compile this in Python 3. It doesn't seem to cause any problems. We can still run it anyway. I wonder if I can catch W5s with the user agent again, because that would be interesting. I'm going to turn interception off for now. I don't like that. I think it's dash dash H. What is it? H0? HH0. So what W5s without this HH0, it will output everything, and you don't want that. It's just too much noise. You want it to do what it's doing right now. And as we fuzz, let's go back to our 2 again. It should still be a bunch of not found. No. What do we got here? We're still fuzzing. All right, we found one. This is better. This is why you want to specify this dash dash H. Otherwise, you'll be scrolling up on a ton of results, which is not fun. So we found random. There's no way I could have guessed this one. So W5 told me that I can use random here. So let's do that. Okay, come on. Oh, it keeps redirecting me, I see. Random equals to slash etc. All right. Before I hit enter, let's use Burp Suite, because I don't like dealing with this browser. I'm not a big fan. Send this to repeater. All right, now I can actually relax and watch how this behaves. So this is what I said it should work. So if I send this, it actually does work. Okay, so we do get some users here. So what I would do is I'll copy these and save them somewhere. But right away, when you get to these users, what you're looking for is anyone with bin bash is going to be interesting because they can sign in. They have a profile. That's what this means here. These users have a profile. So anyone with bin bash, you want no login, maybe not. There might be service accounts though, but bin bash is very interesting for us. Root, usually you don't get that right away. But other users like Elliot here and Royd, these two here are interesting. And so is the user root. So I would keep these 3. Okay. The next thing that you can do here, which I tried earlier, but it didn't actually work. I thought I can just poison the log file if this was an Apache site. That doesn't work. So save yourself some time. Don't try to poison the log files. It's not a thing here. But I always try, because if I can find a log file for an Apache site, for example, I would do it. So from here, what can we do? Let's see if we can. This will be interesting if I can see the home directory. Okay, so, actually, this will be a crime if they did this. No, yeah, you can do that. So it's only the password that we can. All right. what can we do from here? We found some users. We need to be able to verify that we can sign in. So far, we know that these users do have profiles. We just don't know if we can get in, and how can we do that? That's the next part of this. But before I move on, I still have a bone to pick with this file. How is it redirecting my traffic? It's really bothering me. So I would like to find out how this file is redirecting me back to here before I even figure out anything else. So in order for us to read this file, we don't know where it lives. But what we can do is, with local file inclusion, by the way, use this. I highly encourage you to use this Medium article here. I have it in my notes. It does tell you like, hey, this is what local file inclusion is and how everything works. It shows you how to use burp suite. In this case, it tells us we can encode things, or we can just request a file. In this case, it's a PHP file. Let's use a PHP filter because we don't know where this resource is. So I'll start with this one. And this is why I really like burp suite, because I can just go in repeater here and remove etc password and put my PHP filter here. So instead of flag.txt, this one is called file manager.php. Let's see. Most likely it won't give us anything anyway. It's waiting. Maybe we broke it. Let's find out. Yo, did you catch anything? Nothing? We might have to dig for this traffic manually. All right, so this took forever only to bring us nothing. We don't like that. Let's try the base 64 option. So with base 64, I'm just going to try to get the original index of PHP first. All right, there we go. I think, if I'm not mistaken, I can actually decode everything in here anyway. Come on. I should be able to decode this base 64 within burp suite, even though it's not the real one. All right, there we go. I hope you can see this above my head. This is the decoded one by default from base 64, and that's the text. So let's use file manager.php as an example and send that. All right. I do see a bunch of text as well. So let's decode this as well. No, just the base 64. Gosh, this is clunky. All right, come on. Anyone base 64 decoding somewhere? There we go. All right, so this is what it's doing. Like I said earlier, I was like, how is this file manager.php keep redirecting me? If you look at this, it says include file name get. In this case, this is the one that we fuzzed and we found the random parameter. So we found it, but this is what's inside of the file manager.php. And of course, the location it's going back to is the home directory. That's why we keep getting back to index.php. So this is not cool. I see CMO. Oh, okay. This is just a CTF kind of thing, though. I wouldn't count on this. Nobody does this in the real world. But there is a private key here that we need to copy. I don't want to copy it from here because private keys are very sensitive to formatting and everything. So for this one, let me run a curl command to there. I'm going to my temp directory. Let's run a curl command and actually get that same file. And what I'm doing here is I'm saying, hey, curl command, go to this IP address. In this case, mine changed from 125 to 141. It's the same exact request that we send in Burp Suite, but in here. And I like this because then it's easier for me to just do it in one. Pipe it to base64 minus D after you get the results. It's a very crude way of doing things. Then, of course, I'll just copy just the key. And this makes me feel comfortable when I'm copying it from here than copying it from Burp Suite, because I've been burnt by keys before when I copied them and I didn't maintain the original format. ID underscore RSA. That's our key here. It's a private key. So let's go and put that there. The permissions for the key always get me. I think I put 600 or 700 in. One of those is always wrong. Either too open or too restricted. I think it's 700 if I remember. And I put a space here. I don't like that. Mike says, let's go with 600. All right. So we got an ID underscore RSA here. That's our key. Next, going back to our results earlier, the first ones actually, we found out that we have a user Elliot and Rohit and also root. I don't have the original results here. So the biggest problem is port 22 is filtered. So we still have to try it anyway. SSH Elliot at 192.168.38.141 minus I ID underscore RSA. Okay, it's not going to work. Why? Because today we learned something. Filtered ports are a pain. If this is behind a firewall, we need to figure out how to get around that. In this case, SSH is not going to work for us via this method. You will quickly realize after you cannot get in via SSH that if you do a simple Google search that, well, you tried IPv4. What if this system has IPv6? Then you might be asking yourself, well, how do I know what IPv6 address it has? There are two ways that I found out how you can do it. First, you can just ping -6, and then I think there's an IPv6 subnet, entire subnet that you can just ping. It's the FF02. This is the least reliable method. I don't like that. Let's just do 4 per person. We don't want to be pinging indefinitely on a whole subnet here. 4 is too much. This is too much noise. I want 2. So as you can see, I do have IPv6 addresses responding here. Now it's a matter of figuring out which of these IP addresses is my actual victim. That's not going to work. I don't like that idea because what if it's this one? What if it's this one? That's really not cool. These results do show me that I do have IPv6 working in my environment, but I don't like them. So what I can do is let me go and find out which IPv6 address I actually have, so I can come back here and pick it up from here as an easy copy and paste. And that brings us back to Burp Suite. We don't need to base64 that file. This one. Let's change this to 141. So what I'm doing here is I'm saying, hey, let's use the same random. I have it base64. I guess I'll just do that. I'll just do that. I'm just saying, okay, let's get the same file. In this case, the resource is going to be this file, procnet ifnet6. This is a file on a Linux system that keeps IPv6 information. And I had to look it up. I had forgotten how to find this file. I was like, there has to be a file in the system that keeps the IPv4 information, just like the Etsy host file. Actually, why didn't I do Etsy host here? You know what? Forget that. I'm going to Etsy host and see. Yeah, Etsy host doesn't like to talk much. You see, this is why Etsy host is not a reliable source for the IPv information. This is what Etsy host shows us. We don't like that. This file here, procnet ifnet6, is very specific to IPv6. So it will actually give us the information that we are looking for. So let's decode this. I don't know if you needed to encode this file though. All right. So once we decode it right here, this is the IPv6 IP address right here. So it ends with 1BLE. Great. The reason why I like to ping is because then I can come back here and say, oh, where is 1BLE? Maybe I'm blind. Okay, so this should be the whole thing. 29 1BLE 0. It should end right here. And it's an ENP. I left this one because this is a loopback IP address. So that should be there. Unless if this thing is not responding to ping, which we might have to figure out why. All right, I need help. Where is that? Did I just stop my ping before it was done? Where is that IP address? Let me make sure that this thing is actually responding to ping anyway. That is interesting. Am I picking the wrong number? This should be the whole IPv6 right here. Let me send this via curl, make sure that it actually works. Let's do it all in one line. This is for 141. Okay. I thought I was losing my mind here. So this is the actual IPv6. So where's Burp Suite finding this? Is this some cached version of something? I think this is a cached version of something here. This is the real IP address. So this is the one that says CB5. CB5, so this is the one right here. That's why I like to ping, because when I ping it, you see I'm actually cheating here. When I ping it, it gives me the IPv6 in the right format without me having to work for it. If I start with this one, I would have to go and put these colons by myself. So let's ping it. Actually, why would we even ping? Let's do an nmap. -6. Let's see what nmap finds. All right, so this is good. So if you have never done an nmap on an IPv6, this -6 always works for SSH, nmap, and other tools. So I'm saying, hey, let's go using IPv6 on this thing here, on if0, because that's how it responded. Look, this one is now open instead of filtered. So I should be able to SSH is Elliot at that IP address. Oh, come on. If you didn't do this using ping, you would have had to verify that you have the correct IP address. So in this case, I'm actually just going to use the one from ping, because that works. If0 -I of ID underscore RSA on using IPv6, because you need to tell SSH that you're using IPv6, even though it sees IPv6 IP address here. So let's do that. Okay, so it didn't like that. Why? Give me 1 second. nmap worked. So why doesn't this one like my... Is it because of... it says A... I'm being silly. It's FE. Oh, great. Now we have another problem. We need a passphrase for ID underscore RSA. So that's not cool. That's really not cool. So since I got this one right, I'm going to copy this command and save it somewhere for now, because we have more work to do. Thanks, Mike. We have more work to do. So how do we make sure that we get the password? There's this tool called, I believe that's the correct, SSH to John.py. There we go. It's just one. Okay. So I have SSH to John.py here. What I can do is I can convert this ID underscore RSA to be into hash.text or whatever. Let's just name it .text. Then we can brute force this hash here after converting it. Python 2, Python 3, I don't know. All right. So we converted the SSH key to a format that John understands. Once John understands it, we need to just brute force it using roq.txt in this case. So let's do that right now. If you're like, what is he doing? I'm just cracking an SSH key that is a password. That's all we're doing here. And I didn't load it with any threads or anything like that. And as you can see, it's very quick. It found a password of Elliot, but notice how Elliot is spelled here. It's 2 T's instead of 1 T. So even if we try to guess, chances are we will not have done this. So we found the password is Elliot. So now that we have a password, let's go back. I'm not typing that again. There we go. Type this password here, Elliot. All right, so we're in. That was a little bit of fun little things. I guess that's what makes this machine a medium machine. But these skills, I think they're just interesting skills to have, like being able to crack passwords on SSH keys, knowing that we have a filter on SSH where someone thought security through obscurity is a good thing, where they're just moving towards IPv6. Very silly idea, but in this case, we bypassed that as well. Now that we're in, sudo -l. We don't have a password. Does this even work for us? Yeah, it actually does. So it says, hey, we can run without password as this user wrote it here. Let's hope that works. I'm just making stuff up. What am I supposed to do? This looks like an editor. Slash bin. Give me bin bash. What? How do I exit out of here? I don't want to do, maybe I should. That should be an easy one. What is it called? I don't think they have calc in GT4 bins. It will surprise me if they do. No. But I think this looks like a nano sudo. Bin sh? What is this one? Let me see. How do I exit out of that one? It doesn't like the bin bash either. What is this? Oh. Hello. I'm not interested in any of these. Using files, using commands. There should be an easy way. All right, if somebody's doing this with me, let me know what you find, because this is kind of interesting. Let's see. What did I do here? Give me 1 second. We gotta be able to get there. This has to work one way or another, right? Um, mm, what is this? I'm going to look it up. Calc. There has to be an easy solution to that. Because this is just us escaping, so I'm curious what that looks like. All right. Somebody catch me before I make too many mistakes. Okay, so I knew it was this with an exclamation mark, just like I think that's how Vim. Oh, actually, this is what I was thinking with nano here. In this case, it actually goes with an exclamation mark. Okay, so we are in as Rohit, sudo minus L Rohit. This one is not going to work, is it? No, we don't have a password. So I'm just going to make this fail 3 times or 4 times, however long it takes. All right. So every time I do a sudo minus L and it doesn't work, I'll go to their home directory. Whatever this is, maybe it's the base 64, that's the user flag. Do I have bash history? I have calc history. Maybe this person is lazy. Okay, calc history doesn't show me anything. What is this? What is that? Less. Interesting. Whatever that is. Another location that I like to look at is in the OPT directory. People like to put interesting stuff in the OPT directory as well. In this case, I'm not finding anything. You can bring in linps here if you were interested, or you can just first look for, in this case, let's do SUIDs. In my privilege escalation, let's use this one. So SUID files are these files that have special permissions set for them that allows other people to run them with the permission of the owner. In this case, there is an SUID bit here set. When you do this, you need to just look for things that might look out of the ordinary. like whatever this is. There's two here. One of them, which one is not the correct one? I need to find out because I'm not sure which one it is. Give me 1 second. What is this file? I'm going to Google these files here and make sure that they're not the culprits. Actually, that is a normal file. And so is this one. All right. So next time, I won't be digging in these two files. For whatever reason, I thought they were culprits. What is this? This one actually says helper agent. I have not seen this thing very common on Linux systems. So what are you? I'm literally asking questions. Just in case you're curious what I'm Googling, this is what I'm doing. I copy the name of whatever that thing was and put the word privilege escalation afterwards. And I'm like, whoa, this is from 2011. Here's another one from 2021. Thank you, Mike. So this looks like our way in. 2011 is too old. I like this one better. From 2021. Okay. Can we just do this from GitHub? Let's make sure that we verify the version here. This is from 2019. Well, whenever this machine was made. So I'll do a GitHub lookup for that one. Because I don't like the ones from here. And we have a nice write-up here that will tell us all about what we are doing and how we can do it, how we can set it up, and what it's all about, and even the actual in the architecture. This is a really nice article to spend some time trying to understand it, because that will actually help us. Somebody says, is this CentOS? Yo, let us know who you are. There we go. All right. So let's use the 30 the CVE from GitHub here. Found one that actually looks better. Here's a proof of concept, right? It says here, this is how you do. This is how you do it. It's a Debian system, so this looks interesting. I like that. I mean, What language is this? Oh, I'm like, wait. Are you root? No, I'm not. So we will do a wget then. What to do? I think a wget will do us. I'm debating between compiling this on my Kali Linux and moving it over, or just doing it on the actual system itself. Actually, all right, this is the URL for that. It's still trying to call curl, so this is not going to work for us. That's why it's not it's not going to work. Oh, thanks, Word. This is why it didn't work. It was still trying to call curl here. And that's not cool. I'm going to do it myself. Forget what they're doing here. I'm going to do it myself. Let's just do a wget for the actual file. I'm only interested in one file and one file only, the C file. But is it this one or this one? And in this case, I think it's the CVE one, if I'm not mistaken, this one. But I need that. Yes, this is a Spanish box. So I got make C. So if you update this, it will actually work. All right, I'm just going to do a wget for that. You know what? Forget it. Getting the whole thing. Let's clone it here. The only thing that will break my system is if this is a 32-bit and this is a 64-bit, which case I need to just compile it differently. Clear that. Come on. All right. So now I have all the files here. Let me just follow the instructions here. Make and that. If I do that, I'll end up with this file. I'll end up with this file here. Then I can just run that file. So if I want, I can run all this stuff here after make, and I'll end up with a file that I can move to my victim. That looks good. So now I need to move this file, where is it? This one, to my victim. The permissions are already there for us. APA. http://server. I like to compile on my Kali sometimes because the victim might not have the correct version of GCC, or it might be unstable. So by doing this, I actually guarantee myself that it works. The only thing is, if you compile 32-bit binary for a 64-bit system, it will not work. So I'm going to go to this. Yeah. We get HTTP. And I'm getting what file? This one. Let's host it there. ls this one as LA, and there we go. Cannot convert message, cannot open converter from UTT to. Wait a second. What did I do wrong here? Cannot run. Did I not move the correct file? CVE 20214034. So what's up with that? No, that's not the one. This one is the one that I moved last time. This is the one that I copied. You know what? I'm going to move the one that is poc.c. Get this. Let me find the actual original one. Yeah, that was the wrong one. I'm finding a different one. Was if I do, maybe let me just I do have GCC here, so let me just find the C file for that thing. And call it a day. Found this one. This is the original one, the poc.c, for the same exact exploit. So let's just say, let's compile it directly on the system. But at least you saw both ways. It doesn't always work when you compile for a different system somewhere, but we tried. I'm going to name it hacked here. All right. What the hell did I do here? Please don't force me to use nano. I do not want to use nano. I do not want to use nano. Please, not nano today. All right. As you can see, I do have some trust issues. So I'm just going to compile it directly using GCC. Hacked.c. Just hacked. It always makes it an executable. Okay. How hard was that? That was almost making me mad. Okay, so I hope you learned something from my mistakes. You don't want to do what I just did there. I tried to follow the POC from this page here. Well, first of all, I hated this one. I did not like this page script here, which maybe I should have just used. And I was like, yeah, I'm going to do it my way. Right? And I went to GitHub. I was like, hey, what about this one? This is a convoluted way of doing it. Then I found out, oh, somebody actually just has the C file that we can compile ourselves. So why even bother through some script that somebody wrote when we can just go and grab it from Git? So that's exactly what we did there. Otherwise, this is really fun stuff, and it always helps for us to exercise our memory and really know what we are doing. Otherwise, things don't always work out. But this is really cool stuff. I hope you learned something. But before we go, let me go and make sure I check my Security Onion here. I should have at least seen one Suricata event fire. Otherwise, our intrusion detection system is in dire need of tuning. All right, so we did see some SSH outbound. Yeah, of course, Suricata did see that. That was an hour ago. We've been here for longer than an hour, so yeah, I don't think we would have seen anything in the discover here. If I do last 2 hours, the one thing that I want to see is that IPv6 address that we SSH'd to. I'm just expecting to see an IPv6 address. Okay, so we went 3 times here, couple times here, so we don't have a lot of entries. So the client was 201. Destination was that. I think that was the failed attempt. And this time, we should see an IPv6 address that we actually used as a client. So that actually confirms what we were doing earlier when we bypassed the IP address filter and we just went with the IPv6. And look what happened. It used IPv6 on both ends. This is the one we had to find. This is the one for my Kali Linux, which is kind of cool because if you look at the whole IP address, you can kind of tell that they're on the same network, which with IPv6 is kind of different sometimes. All right, let me know if you have anything that you want me to look for, but I wanted to verify that if you do with IPv6, you can see that. Another part that I'm going to check is another part that I'm going to check is that file manager.php. Is it http.uri contains file manager.php? This is the few times that we interacted with file manager.php. And what you're going to see here is the commands that we ran, hopefully. Yeah, this is me trying to find the IPv6 address. Remember when I reached out to the random, it's called proc. So we can see the local file inclusion being executed here. That's all the procnet. But we did more than just the procnet. We did an Etsy host, but it was base64 encoded. I wonder if we're not seeing that because it was base64 encoded. Base64 encoded traffic will look like gibberish here, but yeah, actually no, yeah, my query is wrong because I'm saying http.uri is equals to filemanager.php. However, if we go back to our Kali here and we look at what we did with http.uri, we converted the results into base64. But I was still expecting to see the gibberish in there. Does it encode the whole thing or does it just encode this part here? It encodes the whole thing because the whole result is this gibberish here. So we can't see it. So the only reason why we're seeing this is because I ran it from the command line, which is kind of unfortunate. And it's coming from Zik HTTP logs. All right. I want every instance where this name was seen. Okay, it's the same instances. Okay, so when we do base64 encoded data, we might not be able to see it, which is very unfortunate in this case. But that's what we had. Yes, actually, Mike's point here is very interesting, right? If you're in a network and you don't have IPv6 enabled, and all of a sudden you're showing a bunch of IPv6 within your IDS, that's a big problem. In this case, actually, I didn't have IPv6 enabled in my home network. I actually had to go and look up documentation for Unify because that's why my live stream was kind of late. Was I didn't have IPv6 enabled and it wasn't working, so I had to quickly go and figure out how to enable IPv6 using Unify. And then once it started working, I was able to get it to work. So if you don't use IPv6 for whatever reason, you might want to see why somebody's trying to use SSH with IPv6, which might be interesting. The wget. Yeah, thank you, Mike, for that one. Let's see. The URI should contain something like hacked, whatever that was, right? I did host a file called hacked. What was the file? Yeah, it was called hacked. Destination IP was equals to 192.168.38. There should be only be one GET request anyway. Maybe that one doesn't show up. Oh, actually, you're right. You are right. Hecht was a local file that I created. I am looking for the wrong thing. There we go. This was GoBuster. Looking for CVE. Let's see, what else did we do here? Well, it was CVE-2021. I only got one hit for that. So why did it do that? All right, so that was just one. I'm surprised I didn't see my file moving across the network, which is interesting. What else did I do that might be interesting? So we found a bunch of GoBuster traffic. Let's go and find something. So if you wanted to be sure when GoBuster was running in your environment, I don't know if these wildcards will help you a lot, but this is when we did it. And this is when we ran nmap very quickly, though. It was 29 on HTTP user agent. We didn't have Nikto, but yeah. That was interesting stuff. We don't do a lot of Linux, so this is kind of a refresh every time we come back to Linux and we're like, okay, let's look at things. So thank you for being here. Next week, we'll be back with another Windows machine. I'll post that Windows machine in our channel community page. It's going to be in Windows Active Directory. There's a part of Active Directory that excites me that I've been practicing, and I'm hoping to share with you next week. As always, I'll put some way for you to break in. Then, of course, the machine is going to be how to break into an Active Directory domain controller. Otherwise, this was kind of fun. So thank you for being here. If you haven't, please like this video, subscribe. Otherwise, I will see you next week. Thank you.